Alright, so now we're going to look at some algebraic ways to do limits. We've been looking at mostly graphical ways. So we have some limit laws. So as long as these limits exist, so that's a big deal. They have to exist. And if you're taking the limit towards a number and you plug in, you substitute that number a, so here's just an example up here, plug in that number a, and you get 0 over 0. That is not a vertical asymptote. What that means is you need to do more work. And I'll give you lots of examples, but it means some kind of algebra needs to happen. So you're going to recognize some of these. So here we go. X minus 3 over x squared minus 9. If I evaluate at 3, put in 3, I get 0 over 0. So what I'm going to do is I'm going to factor this denominator out. I'm going to cancel, and then I get this. Now I'm going to use my x equals 3 into here. So I evaluate it at 3 and I get 1/6. So you'll remember this is similar to a graph we've been doing. When we cancel these, we get a whole. And when we have a whole, how we find out what the y value of that whole is we have plugged in the x equals 3. So when we can't, the whole does not change the limit. Okay. Big deals here. The limit is written every time until I plug it in. This is a really big deal. So this limit is here with this. I need to write the limit again as I'm doing the algebra, the limit again, and then when I finally plug in the x equals 3, there's no limit here. It's a really big deal how you write it. So it would be really incorrect to say limit equal 1/6. You have to have the f of x here. You have to have something here. So this is a wrong thing to write, and I will be taking off points for that so that you're motivated to get it wrong, to get it correct. So here I wrote it here. Do not write this. Okay, so evaluating limits, look at it, try plugging it in. If I evaluate it at 3, I get 0 over 0. So you know you get to do more work. You don't have to go and write down that you got 0 over 0. You can eyeball it. So now let's do more work. Let's get rid of fractions. Let's multiply the numerator and denominator by 3x. So if I do, canceling as I go, I get x minus 3. And remember I talked about do not multiply the denominator out. Don't multiply it out. So I'm looking at the numerator and denominator, and I just have to factor out a negative somewhere. So let me factor a negative out of the top. So now I've got these two factors that will cancel. So again, limit every single time. So when I cancel these two, I get a negative 1 left on the top. Now I'm going to evaluate at 3, so I get negative 1/9. So notice, limit here, limit here, limit here, no limit here. So I really want you to watch how I'm writing it so that you're writing it to get full credit when you're doing your work. What to do about this one? Well, I do remember something about a conjugate. So if I do plug in 16, I get 0 over 0. So if I multiply by the conjugate, which is this, so then I'm going to take, say, the limit as x goes to 16. The numerator, because it's difference of square, gives me x minus 16. Remember, do not multiply out the denominator. Leave it with its two factors. Then I see that these cancel. So I have 1 over this. Now can I plug in x equals 16? I can. So that gives me a 4 plus a 4 in the denominator, so I get 1/8. I want to show you a different way to do the same problem. So I want to suggest that you could identify that this denominator can be written as a difference of squares. So this would be root x plus 4, root x minus 4. Difference of squares with a root x instead of an x squared. Then these cancel. And so I get 1 over root x plus 4, and that's 1/8. A little shorter, a little nicer, and I'm always going to be showing you easier or shorter ways so that you have access to them.